So those are the two questions I'm going to talk about today, and I'll tell you some stories about the parasites along the way. So the question of why photograph parasites? For me, it's simple. I think parasites are cool, and I want everybody else to think parasites are cool too. The problem is most people hate parasites. I mean, if you take an orchid or a butterfly or a hummingbird, you know, people love those things. You have to really screw up to make a hummingbird look bad. But parasites, they start off ugly. So I thought, you know, if I can find a way to make parasites beautiful, maybe people will pay attention long enough to learn about how amazing they are. So this is my attempt to make parasites beautiful. The creature on the cover, this is a ladybug that is standing guard over a cocoon of a parasitic wasp. And that parasitic wasp, it starts its life inside the ladybug. The adult wasp injects its egg inside there. The egg hatches, the larva feeds on the insides of the ladybug. And the larva actually knows to avoid the vital organs of that ladybug so that it will keep it alive for as long as possible. And when it's ready to come out, the larva squeezes its way out. The ladybug's still alive. It spins its cocoon, the larva of the wasp spins its cocoon in between the legs of that ladybug. And it actually forces the ladybug to stand guard over that cocoon as the wasp develops into an adult. And the reason is, at this stage, the kinds of insects that have a cocoon stage, they're very vulnerable at this point. They're just sitting there developing to become any other predator insect to come and eat it. And so it's gotten around that vulnerability by keeping this ladybug around to guard it. And the remarkable thing, it takes about 7 days for that wasp to emerge as an adult. And if the ladybug, some of the ladybugs actually survive all 7 days. And after that adult wasp emerges, the ladybug wakes up, it regrows its internal organs, and it can actually survive. So this is the wasp, the adult parasitic wasp, Gynocampus coccinella. It's about 1 centimeter long, very tiny little wasp. And in addition to being able to control the behavior of that ladybug, this wasp has evolved the ability to clone itself. It's called parthenogenesis, and what it means is when that wasp lays an egg, the egg can develop into another wasp without being fertilized by a male. So only a few males of the species have ever been discovered. The vast majority of the whole species is just females cloning themselves. So the question is, you know, how does this wasp control the behavior of the ladybug? And we don't know very much about it, but the scientists studying this are starting to find some clues. So they've discovered there's a virus that lives in the ovaries of this wasp. And that virus gets injected into the ladybug when it lays its egg. The virus migrates into the brain of the ladybug. And it's active there for the duration of the time that that ladybug is paralyzed and standing guard over the cocoon. And if the ladybug survives, the virus degrades after 7 days, and then the ladybug wakes up and recovers. So we don't know how this mechanism works, but we think that that virus is part of this manipulative process. And at that point, you don't even know, is it the virus controlling the wasp, is it the wasp controlling the ladybug? It's an incredibly complex system. So there's a related wasp that actually infects caterpillars. And in this case, the wasp injects many dozens of eggs into that caterpillar. And then those eggs hatch, they feed on the caterpillar, and just like the ladybug, the larvae know to avoid the internal organs. And like the ladybug, there's a virus involved. It's a different kind of virus that helps the wasp in its efforts. And this virus actually changes the metabolism of the caterpillar. It makes it eat faster, eat more, so that there's more food for those larval wasps. And